Hello everyone, welcome to the SQRT channel. In this video, we are going to take another problem from geometry. In this problem, we have a rectangle with unknown length and width. We choose a point inside this rectangle and then we connect the corners of this rectangle to that point. Then we measure the length of the connections from the corners of this rectangle to that point. 4, 5 and 6 are 3 of them, and one of them is unknown. We are looking to find the value that we have for that unknown length. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. To solve this problem, we are going to add a new line. The line that we have in green is the new line that we added. Now we are going to name some of the variables that we have here. As we said, the length and width of this rectangle is unknown. Let's use a and b plus d for the length and width of this rectangle. We also use c for the line that you are seeing here. Based on these, now we are going to try to solve the problem. Note that the green line makes a right angle when it intersects with the side of this rectangle. Based on these, now we are going to move forward to write some equations. To do this, let's start with writing some equations for each right triangle. First of all, x to the power of 2 is equal to b to the power of 2 plus c squared. On the other hand, we can write 5 to the power of 2 is equal to c to the power of 2 plus d to the power of 2. We can also write 6 to the power of 2 is equal to a minus c squared plus d squared. And finally, we can write 4 squared is equal to b squared plus a minus c squared. Now let's focus on the first two equations. We subtract them, and then on the left hand side we are going to have x squared minus 5 squared. On the other hand, on the right hand side we can remove c squared, and then we only have b squared minus d squared. If we move to the second two equations and do the same thing, we are going to have 6 to the power of 2 minus 4 to the power of 2 is equal to d to the power of 2 minus b to the power of 2. Remember, a minus c squared is common and can be removed here. Now we have two equations. If you take another look on the right hand side of these two equations, you can see that for the first one we have b squared minus d squared, and for the second one we have negative of this. What we are going to have is negative x to the power of 2 plus 5 to the power of 2 is equal to 6 to the power of 2 minus 4 to the power of 2. Now let's rearrange it, and then we can get the SQRT root of the result. It's going to be the SQRT root of 25 minus 36 plus 16, which is SQRT root of 5, and that's the value that we are looking for x. Now we are going to move forward and talk about the general solution here. Let's take another look. We had an arbitrary point inside the rectangle. We had 4, 6 and 5 and x for the length of the connections. And we ended up using 4 to the power of 2 plus 5 to the power of 2 is equal to 6 to the power of 2 plus x to the power of 2. We can prove that this is in general correct. And you can always find the value that we have for the connections that is missing by using the length of the connections that are known. If you want a little bit more challenge, you can assume that the point here is not inside the rectangle, and then try to find the solution there. If you find it, let us know in the comment section of this video. Thanks for watching the video. If you would like to see more puzzles, math involved activities, geometries, and problems from different math competitions and olympiads, please subscribe to this channel. Please make sure that you watch other videos and see you in the next video. This is the SQRT channel.